Well, let me just kind of jump to the critique of this, because it's very interesting. First of all, in both Hawking's version and in an alternative version of quantum cosmology that was developed by the Russian physicist Alexander Volynkin, in the technical work, the singularity is still there. In the popular book, Brief History of Time, Hawking talks about a no-boundary universe where he gets rid of the singularity, but he admits that this singularity only vanishes in an intermediate step of his mathematical depiction of space-time, and only in the domain of imaginary numbers, which have no application to the real world.
Hypothetical.
So he says he actually admits this is a mathematical trick, and that when you convert from back from the imaginary domain to the real domain, the singularity reemerges.
That's right.
So he doesn't actually get rid of the singularity, and you see that in his technical work. I've read the papers, okay? So the first critique of quantum cosmology is that you still have a beginning to deal with. It doesn't eliminate what people hope to eliminate by exploiting that tiny loophole right after the beginning.
Right.
The second critique is that the explanations for the origin of the universe offered by the quantum cosmologists are explanations by reference to a mathematical domain, by reference to a set of mathematical equations. They're not yet describing anything physical. It's a domain of pure mathematics.
Right.
And yet mathematics, we know, is conceptual. Mathematical equations are ideas.
Another way of saying that is, what do these numbers mean when there's nothing else except just the numbers?
When there's no universe to describe.
Right.
And we know from experience that ideas, including mathematical ideas, only exist in minds. So even if quantum cosmology is true, it implies that the ultimate explanation for the origin of the universe is a domain of mathematical ideas that must exist in a mind. And so they come right back to the God hypothesis via a different route.
Right.
Now, to underscore that, let me share a quote from Alexander Volynkin, who is a profoundly deep philosophical thinker and great physicist who developed one of the two types of quantum cosmological theories. And this is what he says about this very problem. He says, does this mean that the laws are not mere descriptions of a reality and can have an independent existence of their own? In the absence of space, time, and matter, what tablets could these laws of physics have been written upon? The laws are expressed in the form of mathematical equations. But if the medium of mathematics is the mind, does that mean that mind should predate the universe? And of course, I've argued as much in my book. Volynkin throws this out as a hypothetical question, never comes back to answer it. But it's clear he's thinking very profoundly about this problem. And Hawking himself tumbled to the same insight. In the Brief History of Time, he said, what puts fire in the equations that gives them a universe to describe? It's one thing to have a set of mathematical equations that describe all the possible universes that could exist. It's another thing altogether to explain how the universe came into existence so those equations can become applicable. The equations don't bring the universe into existence. All they can do in the best of cases is describe the possible universes that might exist.